Hi guys, welcome to another episode of MrLopezClasses.com. This is the chapter 9 of our book of corrosion. This is corrosion protection or coding systems. Be careful when you try to use hardware, when you try to use fittings, when you try to buy screws, bolts, when you try to order the fabrication of brackets, supports. All of those should be fabricated in marine grade alloys. Be careful. Some people say, oh, the bracket is fabricated in regular steel but is coated with zinc. That's not good. It's coated with aluminum, but internally it's regular steel. That's not good. You need to select proper marine grade alloys. For that reason, before we start with this chapter, according with our book, we are going to check the video clip that I prepared for marine grade alloys. The alloys recommended for marine environments. The different type of alloys you remember for the shaft, for the propeller, for the fasteners, for brackets. There are a lot of alloys that we start to study in the previous classes, and I create the following video clip in relation with the marine naval alloys. Hi guys, welcome to another video clip of MrLopezClasses.com. In this video clip, we are going to analyze the different type of marine alloys, naval alloys, marine alloys. This video clip at the end is condensated in another great poster, this poster. And this poster once again is available in my webpage www.MrLopezClasses.com. Visit, check on posters, and you found it with other posters, this special poster dedicated to naval alloys or marine alloys. Okay guys, the marine alloys are divided into ferrous alloys and non-ferrous alloys. That's the main division you remember at the beginning of our course of corrosion. Those alloys are divided in ferrous alloys, alloys based on iron, and non-ferrous alloys based on other metals different than iron. The ferrous alloys are alloys based on iron with other ingredients like chromium, molybdenum, carbon, vanadium, silicon, nickel, and other ones. But those are the most important contents into the ferrous alloys. Remember that the ferrous alloys are divided in cast irons and steels, and the steels are divided in low carbon, medium carbon, and high carbon steels. Those are ferrous alloys. But for marine applications, the alloy that is important, the alloy that we need, is stainless steel. Stainless steel is the alloy preferred for marine application, but not all the stainless steels are allowed in marine applications. Stainless steel series 304, excellent. The other name for the 304 is 18A. You remember? 18A. No? How much? 18 is the amount of chromium, and A, the amount of nickel. 18% of chromium and 8% of nickel. Other alloy is stainless steel 316 or 1810. The stainless steel 316L, low carbon, and stainless steel 304L, low carbon. Aqualloy 17, Aqualloy 19, Aqualloy 22, stainless steel alloys used in propeller shafts. You remember in our book of intro, the propeller shafts fabricated in aqualloy 17, 19, and 22. Those are the most common ferrous alloys used in marine application. Remember, the series 304 and 316 are used for hardware, and the series 316 are used in the fabrication of through hulls and other special components in direct contact with the salt water. Right? Those are ferrous alloys. And now we are going to, those are the ferrous alloys. Now we are going to continue with the non-ferrous alloys. The non-ferrous alloys, those are the non-ferrous alloys, based on copper, based on aluminum, based on nickel, and other ingredients like zinc, silicon, tin, beryllium, magnesium, lead, and other additional ingredients. Those are non-ferrous alloys. And we have famous non-ferrous alloys. We are going to check aluminum alloys used in marine applications. It's the aluminum series 5000. Aluminum series 5000, and the most common are the aluminum 5052 and the aluminum 5086. Those are common alloys used in the fabrication of hulls, in the fabrication of brackets, supports. Very, very common. Other series commonly used is the aluminum series 6000. We have aluminum 6060, 61, 62, 63, 6101, 62, 62, 64, 63, and this one I included here is not series 6000, it's the 7075. It's a series 7000, but it's practically the unique alloy recommended for marine applications. All of those are series of aluminum, marine grade, naval alloys, aluminum alloys. And now we are going to check non-ferrous alloys based on beryllium and copper. Beryllium and copper alloys. Those are the most famous. Beryllium copper 172, beryllium copper 173, and the Mold Max is a famous beryllium copper alloy with high resistance for corrosion, high resistance for acids. Yeah, commonly used in marine applications. And now we are going to continue with the nickel copper. The nickel copper alloys. You remember famous nickel copper Monel 400 for the fabrication of propeller shafts. You remember, and Monel K500. Both of them commonly used in the fabrication of shafts. Nickel alloys 200, 201, and 233. Famous nickel copper alloys. Nickel copper alloys. Nickel is magic, remember. Nickel inhibits corrosive properties and increase surface resistance. Okay, those are nickel copper alloys, and now we are going to continue with other famous alloy is nickel bronze aluminum. Nickel bronze aluminum alloys. The most famous is nibral. You remember where you found that nibral? Yes, in the fabrication of propellers. Nibral is commonly used in the fabrication of inboard propellers, because remember, the outboard propellers, the most common are in stainless steel 304, 316, or in aluminum alloy series 5000. Okay, this is the nickel bronze, and the other one is silicon bronze alloys. Silicon bronze alloys, there are famous. The topping bronze is a silicon bronze alloy. The naval bronze C470. Some manufacturers, they say naval brass. I don't want to use the term brass, because brass have high content of zinc, in between 40 and 60% of zinc. And you remember that zinc attract oxygen. For that reason, I prefer mention naval bronze. Silicon bronze 954 and silicon bronze 655. Common silicon bronze alloys. Don't forget, those are the most common alloys, non-ferrous alloys used in marine application. Try to use those alloys for hardware, for fabrication of brackets, supports. If you need fabricate parts for your boat, use Naval Alloys. Use recommended alloys. And try to use fabricators, welders specialized in those alloys. Try to use fabricators, welders with experience in the marine field. Because as you know, in the marine field we need special materials and special techniques. Okay guys, now it's clear that we need naval alloys. If not, we introduce a problem in the boat. However, we are going to check the different type of protections used for different alloys, for different metals. And we are going to start with the different type of coating systems. Coating systems can be divided in two groups: metallic coating systems and non-metallic coating systems. The metallic coatings are divided into barrier coatings and sacrificial coatings. The first one, the barrier coatings. The barrier coatings prevent the intrusion of moisture and avoid that the moisture penetrate the surface, feeding corrosion. You remember? Those are barrier coatings. And there are different types of barrier coatings. The second ones are sacrificial coatings. Like the name says, they are sacrificial. That coating with the time is gone because it's sacrificial. In other words, it's based on sacrificial metals. Provide some degree of a barrier protection, but they produce cathodic protection. If produce cathodic protection, is degraded. Alright, another type of coating is the thermal barrier coating. Thermal barrier coating. Those coatings are used to protect the surface and additionally to create insulation. Those thermal barrier coatings are commonly used in exhaust pipes. In automotive exhaust pipes is very common used, and is used also in home applications, stoves, in the furnace of the air conditioning systems. That system uses thermal insulation materials and in order to reduce the temperature in the surface of the metals. Remember that when the temperature increases, the corrosion is doubled. Each 10 degrees that the temperature increases, the process of corrosion is doubled. For that reason, those thermal barrier coatings are excellent. Use it once again. There are millions of examples, but the exhaust pipes is one of those examples. In the oven in your home, those grills, they are protected with thermal barrier coating. Okay, hot dip coatings. It's too simple. It's basically zinc melted liquid, and you introduce the metal that you want to protect into the melted metal, and the metal cover the surface. Hot dip coating is used to apply coating of zinc, coating of aluminum, coating of lead, coating of tin, and some other metals to protect the external surface. A good example is the galvanizing. Galvanizing is a melted zinc, and you introduce the metal, and the zinc cover the metal. That surface in zinc protect the internal metal. The problem is when the layer of zinc is gone, the metal, the original metal, is attacked. That's the problem. Galvanizing is a good example. It's the process of coating iron, steel, or aluminum with a layer of zinc. Basically, you submerge the metal in a bath of molten zinc. Normally, the zinc is around 860 degrees Fahrenheit, is around 460 degrees Celsius. The zinc is liquid, you introduce the other metal into the liquid, and after that solidify at the same time both of them. The surface is covered with zinc. The zinc creates a covalent reaction in the surface of the metal and protect for a long period of time. It's commonly used in industrial applications in trailers. The trailers for the boats, small boats, they are galvanized. This is steel galvanized. It's good for marine environment, not for the boat, not to use inside of the boat, not to use in direct contact with the water all the time. In marine environments, it's good, but no in boat construction, no in boat reparations. Outside of the boat, probably. Okay? In boat reparations, no. Galvanized steel is widely used in applications where the corrosion resistance is necessary. That's the secret. Okay. Other application is when you apply the zinc, not at high temperature. Zinc metal coating cold. Once again, zinc works as a barrier metal coating, as a sacrificial coating metal, and prevent oxidation. Okay, this is when you apply in spray at ambient temperature, or when you paint with a paint based on zinc. This is called coating. It's not too much efficient. It's for home applications. Aluminum metal coating. This is good. It's aluminized steel. It's a steel that has been hot dip coated in both sides with aluminum silicon alloy. This is good. It's commonly used in exhaust pipes. This process assures a tight metallurgical bond, normally is covalent, between the steel sheet and its aluminum coating. At the end is produced a unique relation in between the coating surface and the internal metal. It's very, very, very common. It's commonly used in air conditioning units, in automotive mufflers, in ovens, in the range of the kitchens, in water heaters, in fireplace, in barbecues, in baking pans. The steel is very useful for heating, and now with the cover, with the coating in aluminum, the heat transfer is faster. It's commonly used in air conditioning units. Every day are more commonly used in automotive applications, in heat exchangers also. That's very, very, very common use. Other common technique, not in marine, is the Gerard dicing. The Gerard dicing is basically you have balls in regular steel and you introduce in a molten metal, zinc normally, with pigments, with colors, and at the end you have a good surface in nice colors. Gerard dicing involves heating the articles. You preheat the metal, the original metal that you want to coat it is preheated, and after that you introduce into the molten metal. The reaction is good, and the surface is covered with a soft surface. It's commonly used in screws, in balls, in tools. There are a lot of tools in different colors for that method, the Gerard dicing. The secret is you preheat the metal, additionally the molten zinc or aluminum, and you introduce over there and cover. The molten metal is impregnated with the pigments in different colors in order to create that appearance. Other type of coating is the mechanical coating. Mechanical coating is very common in industrial applications. I don't like because the surface is not soft. It's like this. Yeah, it's used in fans. Very common in the hardware for fans. The galvanized procedure is mechanical. It's basically a tumble. It's rotating, preheated. The items that you introduce over there are preheated, and when the tumble is spinning, you added powder of zinc, and the powder of zinc with the internal parts at high temperature cover the elements. At the end, when the machine stops, you have balls and hardware covered with zinc. It's the cheapest method of galvanizing, but in my opinion, it's cheap. It's not the best. Yeah, as the barrel rotates, the zinc dust is added on the overheated metal, and at the end you have a surface covered with a powder of zinc. But the texture, in my opinion, is not soft. It's hard. The thickness of the coating depends on the amount of powder that you spray in the barrel. Okay, this procedure is wonderful. The electroplating. The electroplating. You can do the electroplating with silver or with gold. Oh, with silver, you create a battery. You remember? You have an electrolyte. The electrolyte is nitric acid with water. Nitric acid with water. And you create two terminals, the anode and the cathode. This is silver, and the other one is the spoon in steel, for example. And now you connect the battery. One metal becomes positive and the other one becomes negative. The anode releases electrons and pieces of metal. Those pieces of metal go to the electrolyte and are accumulated in the surface of the cathode. And at the end of the day, the cathode is covered with a silver surface. This is electroplating. Nice, no? It's electrolysis. At the end of the day, the piece of silver is eroded because those particles travel through the electrolyte and cover the surface of the other metal, in this particular case, the spoon. You can do the same with gold, and you cover the piece that you wanted with gold. This is the process. Is electroplating. You can cover it with you put the anode in zinc and you cover with zinc. You put the anode in silver and you cover with silver. You put the anode in gold and you cover with gold. And the texture is nice. It's a process that is slow, probably a couple of days, and after that you have excellent surface. This is not used in marine application, but I want to explain as part of this class because it's good for you, because you are an engineer and I want that you know the metallurgical process. Yeah, what is the benefits of that system with the electroplating? Tin is used to coat cans, the cans for sodas, in order to prevent corrosion. That's good. Chromium is used to increase the resistance of the surface. Of course, you remember chromium is excellent for wear. Silver and gold are used to coat jewelry, silverware, because of prevent corrosion and of course increase the value of the elements. Okay, other procedure to cover a surface is when you spray powder of zinc. You can spray the powder of zinc hot or cold. Hot is simple because you produce an arc in between two wires of zinc, and you produce the arc, and air at high speed or oxyacetylene at high speed send the bubbles of zinc, and the bubbles of zinc are on the surface. If you preheat the surface of the metal, the spray is better. This is a technique used hundreds of years ago, and today is commonly used. It's commonly used in industrial fabrication. The fabrication of fans for your home is with this technique, and you can apply the layers that you wanted. The quality of the surface depends if you preheat the metal. Is better because the coating, the bonding is better. This process depends on the operator and depends on the quality of the equipment. There are equipments with oxyacetylene, there are equipments with arc, and there are equipment with air at high pressure. All of them are highly used in industrial applications, highly used in marine applications, especially in steel hulls. Those techniques are commonly used. Okay guys, I hope you enjoy this wonderful video and all of the tips and recommendations. Thank you.